Hi, I'm Eric Woldridge, Associate Professor here at Somerset Community College, and one of my fields and specializations is additive manufacturing. And this presentation that you're about to go through with us is based on that technology and its use in advanced manufacturing and all the different possibilities that you can take advantage of through education, training, and potentially your entire career will be able to use this technology to do amazing things. So what we want to do is just give you a quick introduction. Additive manufacturing, you're more commonly used to hearing it called 3D printing, and it's something that you're seeing a lot in classrooms and in the news here and there. It's getting a lot of cultural backing you'll find it in movies, you'll find it in TV shows, crime shows love to use it and sort of blow its possibilities out of proportion. So we're going to take a look at some of the things that are realistic and are being done right now, plus some of the technology that's going to make it become a more commonplace both in our everyday lives and also our medical lives in terms of saving our life hopefully one day. So lots of possibilities, and what you want to do as we get started is just really open your imagination and be astounded. Lock on to whatever you find the most interesting and explore it on your own time. Google it, YouTube it. There's so many possibilities that you can take advantage of and find out about right now and how this technology can work for you. Doesn't matter if you're 6 years old or 60. This technology has applications for all of us and will be very beneficial in the upcoming years. So settle in and we'll get started. So the basic way to explain additive manufacturing versus conventional or subtractive or any of the other types of processes we have used over the years to make things is to understand that additive basically takes a material of some form and puts it in a certain place. So in watching the video, what you're seeing is a typical FDM printer, additive or 3D printer, additive manufacturing at work, where it's building up a little layer by layer in terms of this overall character design. And this material in question is typical plastic, maybe ABS or PLA. But the end result is, as it builds up each layer, it creates the complex shape. It gives us what we need in terms of overall design, and even allows us to not have to make the part completely solid, as you can see in the video. So the end result is we can do complex creations, save as much material as possible, especially since there's no waste, and get exactly what we need, versus conventional, where material was simply cut from some type of stock or pieced together. This allows for a whole lot of different design applications and innovations that previous methods didn't allow for. So let's take a few seconds to take a look at some of the types of printers. First off is your metal printing system, often referred to as SLS. Then you have your typical desktop, which is the FDM system, and it stands for Fusion Deposition Method. You have your SLAs, which work off resin, and you have your ceramic, which works off basically plunger systems. So of the various types of printers, this is a Delta. It's called a Delta simply because it has the 3 legs and has this vertical axis component sort of going on. However, this FDM printer is typical of the most. You see the plastic is up on top, and it's pulled down through the motor, down into the extruder where it's superheated at the end, and the part is produced. Or actually, each layer is produced as it builds up. This particular one also has a heated plate, which works great for desktop printers in terms of holding the material down. Now, this one is actually making one of our custom lightsabers that we do for Star Wars fans. And this one is your typical printer that works off the linear that you'll see in some other stuff. One of the advantages of the Delta is the fact that the Delta can allow for a lot of vertical height. Now, it's not really great for a lot of smaller parts, but it is great for taller, larger objects. We've actually done a giant pink sword on this one for demonstration purposes. Now, another great thing about the Delta is that it allows you to get a better feel of what's going on, because there's so much clear space here, and each of these axes work in the Z direction, meaning up and down. So as this arm goes up, it pulls the head this way. As this one goes up, it pulls it this way, and that's how you get your overall shape. The real power, of course, always comes from the software used to actually process the designs and turn it into code. One of the real specific questions that folks ask in terms of additive manufacturing are, what is it used for? What type of things are being produced with additive manufacturing that aren't being produced really with conventional? And one, of course, is prototyping. Prototyping devices is so much simpler with additive because we can just produce right then and not have to actually go through a lot of labor-intensive work. And the creations can be very impressive. Another application is automotive. And as you can see, automotive parts result in all sorts of new concepts, new designs, new test situations. Now with automotive, typically those type of parts eventually become volume produced and therefore they'll go to conventional manufacturing. They can typically be faster, but not always. Some companies really are looking into actually doing production with additive manufacturing. Another example, of course, is art. Now, art allows an artist to basically create just about anything they want to with additive manufacturing in terms of complex shapes, designs, materials, everything from ceramics to metals, things that can light up, things that are electronically induced, conductive materials, even materials that change with temperature. So the artistic world in that entire realm has huge applications with additive manufacturing. Another one, of course, is the typical need to replace parts. So replacement parts can involve things such as, a part that breaks off and you have to actually recreate it, but you can't find it in stores anymore. So you can actually take the broken piece and turn it back into what you need. Another example are just parts that don't quite fit, and you can make them better or make improvements. Another sort of unknown application is the use of additive manufacturing to make tools. Now these can be complex tools, they can be tools that someone just comes up with for a specific task, or they can be tools that are actually used in production of other parts. So customization is a huge part of that type of application, goes a lot into machining and those type of cases. So you have a huge number and a huge application base for additive manufacturing of just custom type of equipment and custom type of work. And the list just goes on and on and on of different types of common applications that additive manufacturing can do. Additive manufacturing has a great advantage in the fields of materials or manufacturing that don't involve large volume. For example, the biomedical field, a field where parts that are created that are very custom and also may only need to be done once or twice. For example would be dental work, or perhaps maybe even you consider the cast for an arm break. And in case in point, we have the ability to use 3D printers and additive manufacturing to actually scan bodies, work off MRIs, or also just base it off good old-fashioned x-rays. With that information, we can produce parts, tools, supports, or whatever is needed for that particular patient. Case in point, this is actually one of my students. This is her MRI scan. And that MRI actually was a full body, but we went ahead and printed off just a portion of her lower jaw and spine because of the whiplash effect she had in a car accident, which is why she got the actual MRI to begin with. Now, the advantage of this situation is that her doctors and chiropractors can actually see the structure and the damage done, and they can literally hold it in their hands. Now, this would not be possible if it wasn't for additive manufacturing and the advanced computer technology used to go from model to actual file. So 3D scanning is a major component of additive manufacturing for many reasons. One, it allows us to capture data quickly and efficiently, and the other is it allows us to capture custom data. So biomedical scanning is huge because of the fact that we actually have to scan the person both inside or out to do implants or perhaps for casts or supports. And on the manufacturing or mechanical side, we often use it to recreate parts that may have broken or may need to be modified from existing, especially parts that are older and no longer in service. One of the things that we've done here in the lab is we've worked on building our own scanner systems, typically a hard light structured sensor versus the laser. Lasers are typically a little more expensive, but they are much more accurate and very much used for precision measurements, which a lot of times we don't have to go to that level of detail. What's really interesting though is the advancement of the technology. So for example, about a year ago we were using systems like this, where we actually took a device similar to the Xbox Kinect, or actually an Xbox Kinect sensor, and converted it into actually capturing scanned data. We can also use it for augmented reality. So this system really involved a computer, this particular device, a set of vertical lights, a big rotating table, and that sort of thing. What's really interesting is within less than 12 months, now we're just using a device like this that fits on a typical iPad, which is pretty amazing when you consider how much the technology has been reduced. In fact, right now there's the Google project Tango, which is actually working toward, with Intel, to build this type of chip into the devices themselves. In fact, they already have one in a couple of laptops and more smart devices coming out. So it's very, very possible that we'll be working more and more with scanning technology built right into our devices. So thanks for joining us. Hopefully you've learned a lot today about additive manufacturing, and there's so much more out there. Everything from 3D printing in chocolate to using 3D printers to actually make your own UAVs and drones, even building entire houses out of concrete with 3D printing, or even cars. Many things are going on right now with this technology, and amazing things are happening. So I suggest you take some time to think about this, think about what it might mean for you and your future careers, and come up with some questions. We'll love to hear about those here in a few minutes, and also be thinking about what this may mean for you in the long distance future. Maybe one day you're going to be sitting on your phone ordering a pizza, paying it with it digitally, and then not too long after that a drone's going to come in and deliver the pizza that might have been 3D printed while you're living in your concrete, custom designed house that was made by a 3D printing system. All real technology, all happening right now. It just needs drivers like yourselves to reach out and take advantage of it and do something great with it. So thank you for your time. Hope you enjoyed it.